So, this will be a bonus episode for Numba, and this will also be the last episode of this tutorial series. I may continue this series in the future if enough people are interested in this. So let me know in the comment section. So let's start by importing NumPy and importing JIT and vectorize from Numba. So if you have noticed that we have not imported CUDA, we directly imported JIT. So in this video, whatever we will be compiling will actually be run on the CPU. But Python is an interpreted language. So using Numba and just-in-time compiler of Numba, we can actually compile program for the CPU also. So creating a JIT function for the CPU will not require the NVIDIA graphics or the CUDA library. So let's create a data. So over here I have created an array of random integers. Now I will be using @JIT. So we are not actually using CUDA.JIT, we are just using JIT. So this will be compiled for the processor or the CPU. So this is our functions. Now this function will take in an array and return another array, but depending on the input array, if we encounter any even numbers, the value 0 will be appended in the output array. If we encounter any odd numbers, the value 1 will be appended in the output array. So this is our entire JIT function and we want to compile it. So let's do that. Let's run this. So I'll do time it, and inside my JIT function I'll pass in this x. So if I run this, you can see that time has been taken 29.1 milliseconds. And also there are some long texts over here. So let's see what this text says. So it says compilation is falling back to object mode. So what is object mode? The JIT or the just-in-time compiler for Numba has two modes. One is object mode, another one is no Python mode. So if you have noticed that we have created an empty array and where we are inserting the values integer 0 and string 1. So this kind of mixed data type is fine in Python, but this mixed data type cannot be processed entirely without Python. So whenever this function is called, this function has to heavily rely on the Python interpreter to handle this mixed kind of data inside this output array. That's why this object mode has been inferred, which means the Python interpreter will be invoked during the execution of this function. So if we want to mention that we don't want the Python interpreter explicitly, we can do no Python equals to true. So right now, whatever happens, this JIT function will not rely on the Python interpreter. So let's run this. And as expected, we got an error because this mixed kind of data type without the Python interpreter is not possible to be processed. So let's change this to integer 1. And now if we run this, as you can see, only 9.31 microsecond has been taken. So this is marginally faster because right now the Python interpreter is not invoked during the execution of the function, and this function has been compiled into a binary and stored in cache. So this execution of this function is much more faster. Now we just saw that the mixed data type is a huge issue. What if we do output equals to an empty list, and instead of indexing over output, which we cannot do because it is empty right now, we can actually do append. So output dot append, then we'll append 0, and similarly we can do output dot append, then we can append 1. Now if we run this, we did exactly the same thing, but this timing is in milliseconds, while previously we got in microseconds. So right now we are much more slower than before. So this append method or this list data type is not actually directly supported. So when we want to compile a JIT function, working with arrays will be much more faster than working with lists, because lists are a Python exclusive thing. And although we are doing no Python equals to true, a representation of list has to be created inside these functions, because list can hold multiple type of data types, but whereas the typical implementation of arrays will be of only one kind of data type. So every time while appending anything, it needs to resolve the data type of the entry that we are inserting in the list. Even though we are not passing mixed values, it still needs to identify the data type of the value we are passing in. That's why this method is also slow. So numpy.array will be the best choice to go forward with if we want to accelerate our functions which can run on the CPU also. And the same concept of not using a list also applies in the CUDA.JIT decorator. So moving on to the next thing, we have imported something called vectorize. So let's use that. So after the vectorize operator, my code logic is same. So if the number is even, we'll go with 0, and if the number is odd, we'll go with 1. But over here, we're not looping over some for loop. We have only written the code logic. Now this has a special property because of vectorize, because it can take a single number. So we can do something like func vectorize, then we can pass in 3. And if we run this, we can see that the output has been returned 1. So if we pass 2, which is an even number, output will be 0. But then again we can also pass an array, and it will be run over the entire array. So no need to use loops. Let's do the time it. Now as you can see, although the vectorize can work on the single number or an array, the vectorize takes a little bit longer because it still has to decide whether the data type passed in is a single number or an array, and then it will create the appropriate functionality to deal with the single number or to deal with an array. After that, the execution will happen. So using vectorize can be very flexible when you have different kind of data shapes, but if your data shape is defined, going with a JIT function with proper structure is always faster. And that's it. I hope the Acceleration Basics tutorial series based off of Numba and CUDA was helpful to you. Also, feel free to let me know how this tutorial series helped you accelerate your applications. Thank you for watching this video. Thumbs if you liked it. Do share it with your friends and family. And make sure to subscribe for more content and let me know in the comment section below.